go.
Oh, all right. So we're going over square roots. Square root is an opposite of an exponent. It's taking the numbers down a power. Do you all know what I mean when I say taking the numbers down a power?
No.
No. All right. All right. First off, do we know what exponents are?
Yes.
All right. How if I have 3 right here, where do I write my exponent?
On the right hand corner.
Right here? All right. So, what would this equal?
9.
9. And how did I get 9?
I'm going to do my 10.
I multiplied 3 times 3. Spectacular. You all remember that when we did this for managers? All right. So, with that, yes, Ladare.
Well, I'm confused. It says 3 times. How do you multiply 3? Not how do you multiply what?
Excuse me, I think Ladare was asking me, not anybody else in the class. Go ahead.
I'm confused. I thought you had to multiply 2 times.
3 times 3.
No, I'm saying, like, how did you understand? I'm not. I'm trying to figure out how do you understand when you multiply.
Are you talking about the properties of I guess having an exponent, knowing that exponents mean to multiply.
Oh. That's pretty much what the answer is. Having an exponent means to multiply. You're multiplying this number 2 times.
Talk about Mr. Sturtevant.
Do you see it? You're multiplying this number here 2 times. So if I had 3 to the 4th, then that means I'm multiplying 3 4 times. So it'll be 3 times 3 times 3 times 3.
Oh,
okay.
So you multiply it by, so remember, I thought you had to multiply it by the 2.
No, you're multiplying by its own number.
But that is a common mistake, and the number that Mr. Sturtevant is referring to is the base. So the larger number is your base. The exponent will also sometimes be known as a power. Okay? So the power determines how many times you multiply the base to itself. So you see how Mr. Sturtevant wrote number 3 to the second? It's telling you to multiply 3 to itself 2 times. And then what was the next one? 3 to the 4th? 3 is multiplying to itself 4 times. Yes, sir.
All right. Ms. Baptist kind of took what I was about to say.
Sorry.
It's all right. So, this is called what? 3 to the second power. So if I'm finding the square root,
Or squared.
or 3 squared, what's else going off with taking it down a power?
Okay.
So if I'm doing the square root of 9, I'll be taking it down a power because the square root of 9 would be 3, and that's because 3 times 3 would give me 9. So do you see what I mean by taking it down a power?
Yes.
It'll make a little bit more sense once I go further.
And then, Mr. One more thing I was going to say too. Think about it from the aspect of opposites. The opposite of addition is to what?
Subtraction.
Subtraction. So the opposite of multiplication would be what?
Division.
Division. So the opposite of squaring something is to take the square root. Okay? I'm sorry, go ahead.
Okay. No, that might have helped. I didn't even think about that for second and third quarter. All right. Perfect square. Do we know what a perfect square is not in geometry terms?
No. A what?
Perfect square.
No. Even number.
4. Why would 4 be a perfect square?
Because even.
No. No. Like I said, not in geometry. Do your CA test. All right. So 4 would be an example of a perfect square. What numbers can I multiply to get 4?
2 times 4.
1 times 4 and 2 times 2. So, what makes a number a perfect square is that when you multiply, what's the way I can say it?
The factor has to be the same.
Factors, thank you. The factors have to be the same. So, my factor here is 2. I'm multiplying it by itself, which is 2, so that gives me 4. That's what makes 4 a perfect square. Can anybody give me an example of another perfect square?
6.
8. 16.
16. Why would it be 16?
Because 8.
4 times 4.
8. 9.
9.
81.
Why would it be 9?
Cause you do like 3 times 3.
3 times 3.
Is 81.
All right, 81. Why would it be 81? 9 times 9. So could I say that 100 is a? Could I say that 100 is a perfect square?
Yes.
Why?
10 times 10.
10 times 10. Will I say what DeAndre said? 121.
Yes.
Why?
11 times 11.
11 times 11. Could I say that? Let's see. 49 is 1
No. I mean, yes. No.
because it's
7 times
7 times 7. Could I say that 62 is 1?
No. Wait. No.
No. Could I say that 8 is 1?
Yes. No.
Why?
No.
Because 4 times 2 is 8.
Is
2 times 4 is 8.
no. Because look at all of these. 2 times 2, 4 times 4, 3 times 3, 9 times 9. We're multiplying by the same number. So when you said 2 times 4, is 2 and 4 the same number? Okay, so 8 would not be a perfect square. All right. If I were to say 36,
Yes.
why?
6 and 6.
6 times 6. So we understand what a perfect square is?
Yes.
All right. I'll write a definition for you. It's the product of 2 factors that are the same number. All right, so it's the product of 2 factors that are the same number. All right, this is my radical symbol. My radical symbol represents square roots. Yes, Aaliyah? Oh, you're just stretching? Putting your hand in the air, waving like you just don't care? All right. We have 3 different types of square roots that we try to work out. We have we have 3 different types of square roots that we work out. We have the perfect square, the factor out square roots, and the non-factor roots. For perfect square roots,
I don't understand.
can anybody take a wild guess and tell me what the answer to that would be?
4.
4. Why would it be 4?
Because 4 times 6.
4 times 4 would give me 16. So if I had this one,
What could be 6? 6.
why would it be 6?
Because 6 times.
You write that down.
Excuse me.
Bless you.
You don't want to take
Bless
this.
you.
If it's talking.
What would this be?
Oh. 15.
15.
Oh, and I guess. Oh my God.
What would this one be?
12.
12 times 12.
All right. Perfect square seems simple?
Yes.
Wonderful. All right. Next one, the factor out square roots. All right. Can anybody tell me what the prime factorization of 75 is? Or how I would do the prime factorization for 75? Are you done with your CHS? Oh, okay. I thought you were taking yours. I'm sorry. All right. What was the
Oh, never mind.
Never mind. All right. Go ahead, Joe.
You can do this 3 times 15, and then you have to break 15 down.
3 times 15. That would give me 45.
3 times 25.
3 times 25. All right. 25 times 3.
And then break 25 down into 10 and 5, or 5 and 5.
You write this down.
Are you done with your CHS? Yes, write it down. This will help you. Yes, Tashawn?
I learned this before.
I know.
But I want to.
I would hope so. I would have hoped you would have learned it in 5th grade too.
Yeah, I learned that.
All right. So, and what would my answer be, Joy?
5 times 5 times 3.
Or
5 times
3 times 5 squared. You were right. But the proper way to say it, or in ascending order, would be 3 times 5 squared.
Okay.
All right. What about 76?
Midget.
What is 76? It's an even number. All right. Since it's an even number, what are all even numbers divisible by?
2.
2. So what would 76 be divisible by? What would it be if I divided 2 by 76 or 76 by 2? 38. Thank you. Woo! I struggled with that one. All right. Can I break 2 down any further?
No.
All right. Can I break 38 down any further?
Yes.
What can I break it down to?
16.
16.
2 times? Yeah, 2 times 16.
2 times 16 will give me 32. 2 times 18 will give me 36.
2 times 19?
2 times 19.
Or 19 times.
Can I break 19 down any further?
No.
Yes. I mean, no.
Yeah, no.
All right. I was going to let him tell me what the answer was. All right. So, I'll write 2 squared times 19. So we understand prime factorization?
Yes.
All right. Also, if I have a number without one of these exponents here, the understood exponent is 1. Because 3 to the first power would just be that, a number to the first power would just be that number. Because you're just multiplying 3 times 1, basically. But it will be that same number. So the understood exponent here is just 1. Just a little FYI. All right. Now that we have this, if I give you this problem here, the square root of 75. You can take what you have here to help you solve this. So we know that the square root of 75, if we factor it out, would be 3 times 5 times 5. I would then turn that into 3 times 5 squared. And then I would take my number that has the exponent and I would put it on the outside without the exponent and leave my number without the exponent on the inside, or my number with the exponent of 1 on the inside. So let me make sure I write this down for you. Put numbers with an exponent on the outside for even roots. All right. So do we see how I worked my way to here?
Somewhat.
All right, let me show it to you again. So we factored 75 out, correct?
Yes.
All right, which gave us 3 times 5 times 5. I combined the 5 times 5 to make it 5 squared. I took my number that has the exponent and put it on the outside. And I left my number without the exponent on the inside. That's all you have to do.
Very similar to when we deal with absolute value and we took the absolute value of a number and it came out of those two parallel lines. Same thing here with the radical sign. The minute you take the square root of 25, which is 5 squared, we know the answer is 5. So 5 comes outside of the radical, and like Mr. Servant said, 3 is going to remain because we cannot take that 3 is not a perfect square. So that's why 3 remains. Give one more, Mr. Servant, please.
And that one right there.
Oh,
77.
okay.
All right, so based on what I have right here, do you think you could tell me the steps for square root 76?
That would be 2 times
2 times 2 times 19. All right. And then I will go to
19, 19 times squared, or 2 squared.
2 squared times 19.
And
Then I would,
put 19 on the inside. and
I'll
2
leave
on the
19 on the inside and put what on the outside?
2.
2.
Because 2 squared is equal to what number?
4.
4. And the square root of 4 is what?
Oh.
2. So that's why 2 comes on the outside. Because you took the square root of 4. Just like how Mr. Servant went back to perfect squares and listed them out. 4 is equal to 2 times 2. You are mimicking what you saw in that first column. 4 is equal to 2 times 2. 16 is equal to 4 times 4. 9 is equal to 3 times 3. So when he went and did the square root of 2 squared, the 2 comes out because that's equivalent to 4. And the square root of 4 is 2. Give him one more, Mrs. Sturdy.
Sure. All right.
Please.
Huh?
I said please. Okay.
Oh, gotta make it quick. Let's see. 72. Yeah, 72 will work.
Mm-hmm.
If I factor out 72, what could I start with?
2.
2 times 2 times 36. Can we break 2 down any further?
No.
Can we break down 36?
Yes.
What would it be?
6 times 6.
6 times 6.
And you can bring both 6 to 3. 2. Yeah. 2 times 2. And then, yeah.
Oh, I should have done it differently.
They really didn't have to go that far.
They didn't, but. So the final would be 2, 3, 4.
Just so much.
2 to the 4th times 3 to the 2nd. All right. I guess I should have left it at 6.
No, keep it like that. If you do that 2 to the 4th, put them back into square roots. We
Right.
just step it up a notch to the algebra level. So if you take it into that radical, because you're going to do algebra regardless. So just look, I don't get in the hang of it. So when you have that 72, and then you had that square root of 2 to the 4th times 3 to the 2nd. All right, square root of 4 is what, class? 2. And your base happens to be what?
4.
What's your base? Your base is that big 2. So therefore, the square root of 2 to the 4th power would be 2 what? Okay, I'm going to break it down one more time. So going back to 2 to the 4th, we all agree that square root of 4 is 2. And we have a common base. Mr. Sturvey, point to them for the base for me. A common base of 2. So if I ask you to take the square root of 2 to the 4th, what do you think your answer would be? I'm going to see how many people are going to take it up a notch from me. It's going to be what?
16.
Not 16.
I think it's 12.
All right, so if you, okay, let's entertain that. If you say 2 to the 4th is 16, right? The square root of 16 is what? 4, which can be rewritten as a base of 2 having an exponent of what number? Let's take it up a notch on thinking. You said square root of 16 is 4. What is another way? What's another way you can write 4 using a base of 2?
4 times 2.
2 what? 2 to the what?
2 times 2.
Thank you, ma'am.
Oh,
2 to the 2nd is the same thing as 4, is it not?
Oh.
So the square root of 2 to the 4th is 2 to the what?
2nd.
Perfect, which is still equivalent to what? 4, which is 2 to the 4, which is still equal to 16. What I'm trying to get you to understand, Mr. Sturvey, write that down for me, please. So that onto the right side of it a little bit. 2 to the 4th, which we know is that 2 times 2 times 2 is also equal to 16.
Oh, I get it now.
Write that 2, when you that 2 to the 4th, write the 2 is equal to 2 times 2 times 2, which is also equal to 16.
6, 8,
And then 2 squared is equal to 4, which is the square root of 16. What I'm trying to get you all, what we're going to try to get you all to do is look at multiple representation of numbers.
What?
100 pennies is the same as me having 20 nickels, which is the same as me having 4 quarters, which is the same as me having 10 dimes, which is the same as me having 2 50-cent piece. They're still $1. So I need you to start looking at how to flip numbers around so they're still equal to the same thing. So with that being said, 3 to the second power. 3 to the second power is equal to what, class? 9. What's the square root of 9? 3. So therefore, on the outside of the radical, you have 4 times my 3.
Isn't it 3 and 2?
Which gives me what? And what should be on the inside?
12. What?
And we'll put a star beside. We'll talk about that a little bit more in detail.
Oh, because 6 times 2 equals 12?
That's right.